Students, today we'll be solving the 2022 Physics IGCSE October-November 2022 paper 2. So we are doing the paper 2 variant 1, that's paper 2-1. Be attentive throughout this class, please. Alright, let's go straight to what we have to do for the day. Question 1. Which measuring instrument is used to measure the diameter of a thin metal wire? Diameter of a thin metal wire, you can imagine how small it will be. So when you want to take very small measurements, you use the micrometer screw gauge. Option D. Let's go straight to question 2. A car starts from rest. The table shows the reading from its speedometer every 10 seconds. Which rule describes the car's motion in the first 30 seconds and in the last 30 seconds? The first 30 seconds, that will be from here to here, and the last 30 seconds, that will be from here to here. Okay, you know, the first 30 seconds, that will be from 0, you count, from 0 seconds, you count 10, 20, 30. That's the first 30 seconds. So, motion during the first 30 seconds, number A, we have non-zero acceleration. Yes, non-zero acceleration. Here you see that the speed increased from 0 to 4 meters per second. So there's a +4 here. In the second case, the speed increased from 4 to 8 meters per second. That's plus another 4. In the third case, the speed increased from 8 meters per second to 12 meters per second. That's plus another 4. So you see that you keep adding 4, 4, 4 for the first 30 seconds. You keep adding 4, 4 seconds. Okay, that means there is non-zero acceleration. That shows that the body is accelerating because the speed is not constant. Then during the last 30 seconds, that's from here to here, this is the speed during the last 30 seconds. Do not forget that this column here represents the speed. So if you are talking about the speed during the last 30 seconds, we are talking about this part of the table. And you see that the speed is constant. The speed is 12, 12, and 12. So since the speed is constant, and that shows that the body is not at rest. No, the speed is constant. Acceleration 0. No, acceleration is not 0. The fact that the speed keeps increasing throughout the first 30 seconds shows that acceleration is not 0. So where do we have non-zero acceleration and constant speed? Option D, non-zero acceleration and constant speed. That is the correct answer to question 2. Let's go straight to question 3. Which property of an object is a consequence of the effect of gravitational field acting on it? Gravitational field acting on it. Which property is D, weight? Why? Because weight is equal to mass multiplied by the gravitational field strength acting on every object on the earth. Question 4. The diagram shows the dimensions of a solid rectangular block of metal of mass m. Which expression is used to calculate the density of the metal? Do not forget that density is equal to mass divided by volume. So if m is the mass, v is the volume, how do you get the density? You know, the mass is m from the question. What's the formula for volume? Volume is equal to length times breadth times height. In this block, you can see the length is p. The length is equal to p. The breadth is q. And the height is r. Okay, good. So you can have it as p times q times r. Yeah, the height is r. So that is the expression for the volume. Now let's use this expression for volume. Let's use it to replace v in this first equation for density, mass over volume. So that means the density is the mass divided by, instead of writing volume here, what are we going to write? We are going to write this expression that represents volume. So you write P, yeah, times Q times R, which is option B, M over PQR. Number 5, a wheelbarrow has weight W of 140 Newton. A vertical force F is needed to support the wheelbarrow in the position shown. Sorry, which vertical force F, good, which vertical force F is needed to support the wheelbarrow in the in the in the position shown. Now, if you look at this question, is a question on moment, and this is the pivot. This is the pivot. The fixed point is here. This is the pivot. This is the force. The force F is the force producing the anti-clockwise moment. Okay, while the force producing the clockwise moment is the weight. Good. What's the distance between the force producing the anticlockwise moment and the pivot? That distance is from here to here, and that is what we have here as 1.4 meters. Okay, these lines might make it a bit confusing, but don't focus on too much on the lines, focus on the information that is being passed. This is the pivot. So the distance between the force F and the pivot is from here to here, which is 1.4 meters, right? Good. So we use the question that total clockwise moment must be equal to total anticlockwise moment. Okay. The force producing the clockwise moment is W. Okay, yeah, that's this force. And the distance for the clockwise moment, that's the distance between the pivot and this W. How do you get that distance? D1 equals to 0, sorry, D1 is equal to 1.4 minus 0.8. Yeah, that's how you get the distance from pivot to W. Yeah, good. That's how you get the distance from the pivot to W. Let me use a different color of marker so everything does not look mixed up. So the distance between D1 and W, the distance between the pivot and W is D1. That's the distance D1. And you get it by subtracting 0.8, okay, from everything. Yeah. So when you remove 0.8 from everything, then you get the remaining, which is the D1, right? Good. So let's remove all of this and solve the question. So 1.8, 1.4 minus 0.8, that will give us 0.6 meters. That's your D1. Okay. Now let's substitute F, the force F1, the force producing clockwise moment is W, multiplied by the distance D1 is 0.6, okay, equal to, what is F2? F2 is the force producing anticlockwise moment, which we do not know, right? But here you were told that the weight is 140 Newton. Yeah, so I'm supposed to put 140 Newton for W, not just writing W. I'm supposed to write 140 here. That's the value of the weight. Good. So our force producing the clockwise moment is F, whose value we do not know. F multiplied by, what's the distance? D2. That's the distance between F and the pivot, which is 1.4 meters. So we put 1.4 here. 1.4. So to get F, we divide both sides by 1.4. Divide by 1.4. 1.4 will cancel out 1.4. That means F is equal to 140 divided by 1.4. That will give us 100. 100 times 0.6, that will give us 60 Newton. If you evaluate this with a calculator, you get 60 Newton. That makes option A the correct answer to question number 5. Question 6. A car is traveling around a circular track at a constant speed as shown. In which direction is the resultant force on the car? You see, when a car is traveling around a circular path due to circular motion, there will be an outward force which we call the centrifugal force. Okay, so we need an inward force to balance it. Okay, but when there's no inward force, usually the inward force is produced by the friction between the tires and the road. Okay, but when the friction is not enough to withstand that centrifugal force, the outward force, then the resultant force will be in the direction of the centrifugal force. Okay, it means the centrifugal force is greater than the centripetal force. Okay, so the direction will be in the direction showed by the arrow D. Okay, Yeah, a car is traveling around the circular track at constant speed. In which direction is the resultant force on the car? So the resultant will be in this direction. But that's the outward force. But usually, this outward force is being balanced by an inward force, and that inward force is called the centripetal force on the car. Okay, good. So the centripetal force will be in this direction. That's the inward force that is needed to keep the car around a circular track. You get it? So when an object is moving around a circular path, there will be an outward force that tends to throw it outside the circular path. Okay, but since the object is moving around a circular path, in order to maintain it moving around a circular path, then there is an inward force needed for this purpose. That force is usually produced by what holds the object. If it was a stone that you are tying to a string, then that inward force will be produced by the string. In this case of a car, the inward force that is needed to balance this outward force of the, okay, you need to balance this outward centrifugal force. The inward force needed to balance it will be provided by the tires, the friction between the tire and the road, and that inward force is called centripetal force. In that case, we select option B as the correct answer to this question. Yeah, so B, that's the inward force, and that will be the resultant in this case. Yeah, that inward force needed to balance it will be the resultant force. Okay, let's go straight to question 7. The diagram shows parts of a hose used by a firefighter. So there is a firefighter that uses this hose, water moving in. Okay, the volume here is bigger than the cross-sectional area here is bigger than cross-sectional area here. What does that mean? It means pressure here will be higher and pressure here will be lower. Why? Because of change in volume. Let's read the question. 15 kilogram of water flows through the hose each second. Which force is applied to the hose by the water? You know, force is equal to mass multiplied by acceleration. Okay, now you have the flow rate, that is mass per unit time. Force is also equal to flow rate multiplied by velocity or speed. So the flow rate, the mass per unit time is 15 kilogram per second. Okay, 15 kilogram per second. If you multiply it by the speed in which the water is moving, which is what? What's the speed? Okay, so water moving in at 1 meters per second, water moving out at 6 meters per second. Aha, good, good, good. So you multiply it by the change in speed now is from 1 meters per second to 6 meters per second. So that means our change in speed will be 5, right? Good. Our change in speed will be 5. So change in speed would be 6 minus 1. That will be 5 meters per second. So if you multiply this by your change in speed, which is 5, 15, this is second, please, kilogram per second. 15 kilogram per second multiplied by 5 meters per second. Let me erase all of this so that this calculation will be far clearer. Okay, flow rate is force is flow rate multiplied by speed. Okay, in this case, since there are different speed, so flow rate will be force will be flow rate multiplied by change in speed. Okay, our flow rate is 15 kilogram per second multiplied by our speed would be 6 minus 1, 6 minus 1, that would be 5 meters per second. Okay, if you multiply 15 by 5, you get 75, and if you multiply kilogram per second, multiply it by meters per second, you get kilogram meters per second square, which is the same SI unit for force. Okay, 75 Newton. Take note that the Newton is the same thing as the kilogram meters per second square. If you want to know how we got this through dimensional analysis, you watch the video in the link up here. Follow this link up here and watch the video on derivation of SI unit. You understand how this SI unit was gotten. Let's go straight to the next question. Question 8. The brakes are used to slow down a car. Into which form of energy is most of the kinetic energy converted as the car slows down? You know, a moving car possesses kinetic energy because it is moving. But when it slows down, the kinetic energy will be reducing because the speed is reducing. So that kinetic energy that is reducing, what is it being converted to? Because you cannot say that kinetic energy has been destroyed. So it will be converted into thermal energy. Yeah, because when you apply brakes, the brake pad will grip the tires of your car and it will produce friction. Friction produces heat. You get it? Good. So that is thermal energy. Heat energy is thermal energy. Question 9. An object has kinetic energy of 200 joules. A constant resultant force of 190 Newton is applied in the direction of its motion through a distance of 10 meters. What is the final kinetic energy of the object? Now take note that initially the kinetic energy of the object is 200 joules, right? 200 joules. Good. That is the initial kinetic energy. Now you are adding a kinetic energy of what? The kinetic energy you are adding is equal to work done by that force. And what's the formula for work? Force times distance. So when you do force times distance, you get this change in kinetic energy. What's the force? The force is 190 Newton. What's the distance? The distance is 10 meters. 190 times 10, that will give you 1900 joules. By the time you add this change in kinetic energy, which is 1900, add it to the initial kinetic energy. This change in kinetic energy, add it to the initial kinetic energy, that will be 1900 plus 200. That will be what? 2100 joules. Get it? Good. 2100 joules, which is option D. That's the correct answer to question 9. Option D. So we shade option D. We go straight to question 10. The statement describe what happens when the power of a machine is increased. Number one, we have work done in a given time decreases. No. Work done in a given time increases. Yes. The time taken to do given quantity of work decreases. Yes. The time taken to do a given quantity of work increases. No. Only 2 and 3 are correct. That is option C. We go straight to question 11. A manometer contains water. A manometer containing water is used to measure the pressure of a gas supply as shown. So this is to gas supply, okay, and this is exposed to the atmosphere. So since this part is lower in position, that means the pressure of the gas is pushing the water down. Hence, the pressure of the gas is higher than atmospheric pressure. The question says the density of water is 1000 kilogram per meter cube. What is the pressure of the gas supply? How do you get the pressure of the gas supply? We have to calculate the change in pressure as what? Density of water times gravity times height. Why? Because it contains water. We are told that the density of water is 1000 kilogram per meter cube. So you have 1000. Gravity is always 10. What's the height? The height is the difference between this value here, which is 10, and the highest value, which is 40. 40 minus 10, that will give you the difference from here to here. 40 minus 10, okay? 40 centimeters minus 10 centimeters gives you 30 centimeters. This 30 centimeters, you have to convert it to meter by dividing by 100. That will be 30 divided by 100. That will give us 0.3 meters. That is the height. The height is 0.3 meters. So we have 0.3 in place of our height. 1000 times 10 times 0.3, that will give us 3000. That will be difference in pressure, okay? But the question requests for what is the pressure of the gas supply. Now, the actual pressure of the gas supply will be this change in pressure plus atmospheric pressure. You get it? Yeah, so the pressure of the gas supply must be 3,000 added to atmospheric pressure. That's 3,000 above atmospheric pressure, okay? Sorry, um, density. Yeah, 3,000 above atmospheric pressure. That's option C. 3,000 pascals above atmospheric pressure. Question 12. A fixed mass of gas is trapped in a container. The temperature of the gas is increased, but the volume of the gas is kept constant. How does this change affect the average kinetic energy of the molecules and the pressure on the walls of the container? Now, when temperature of a gas is increased but volume is kept constant, okay, take note that pressure is directly proportional to temperature. So that's when volume is constant, okay. So when you are increasing temperature, automatically you are increasing the pressure, okay. Now, when you are increasing temperature of a gas, what is happening to average kinetic energy? Do not forget that temperature is the average kinetic energy of the molecules of a substance. So when you are increasing temperature, you are increasing the average kinetic energy. You get it? Yeah. So the average kinetic energy must increase. The pressure must also increase because increase in temperature leads to an increase in pressure. That makes option A the only correct answer in this case. Question 13. Which role correctly describes boiling and evaporation of water? In the case of boiling, bubbles are seen, correct? That is correct. In the case of evaporation, it occurs at the surface only, correct. Option B, bubbles are seen, yes, occurs throughout the evaporation does not occur throughout the liquid. Option C, no bubbles, that's not correct. Bubbles are seen during boiling. Evaporation occurs at the surface only, correct. Option D, no bubbles, that's not correct. So it's only option A that both suggestions are correct. So we pick A. Question 14. The diagram shows a liquid in glass thermometer. You have the bulb, you have capillary tube. Which change increases the sensitivity of the thermometer? Narrow tube, narrow tube, narrow tube. Yeah. When the capillary tube is narrow, little increase in temperature would lead to a large rise in the reading of the bulb, you see. So when this tube is narrow, little increase in temperature would cause this tube the level of mercury to rise quickly. You get it? But when the tube is wide, okay, when the tube is wide, okay, a large increase in temperature, an increase in temperature, or rather, you mean when the increase in temperature of the one with narrow tube is equal to the increase in temperature of the one with the wide tube, the rise in level might not be as much, might not be that much, okay, it might just get to this level. Why? Because the tube is wide and the volume is wide. Okay, so that volume means it is consuming, it is taking up, it is accommodating much liquid, okay. Yeah, so it is accommodating much liquid, but when the tube is narrow, it won't be able to accommodate much change in temperature. Any little change in temperature, it causes the level of liquid to rise, okay. So thinner glass around the bulb increases the sensitivity in narrow capillary tube. Question 14. Narrow tube, option A. Question 15. The diagram shows a liquid in glass thermometer with uniform capillary tube. So we have the liquid, we have the capillary tube, all parts of the liquid in glass thermometer are shown. Now, what does this mean to us? The question says, which temperature is indicated by the thermometer? Okay, in this case, you have to do some conversion. Okay, in this case, you have to do some conversion. How do you do this conversion? Now, look at this. The 0 degrees Celsius is at a distance of 80 millimeter. 100 degrees Celsius is at a distance of 88 millimeter. That means the fundamental interval now, the gap between 0 and 100, the gap between 0 and 100, on the temperature scale, you have 100 minus 0 gives us 100 degrees Celsius. That's fundamental interval. Now let's look at the length of mercury. At 100 degrees Celsius, we have 88 millimeter. At 0 degrees Celsius, we have 8 millimeter. So the distance, okay, the distance of the fundamental interval, the distance for the fundamental interval would be 88 millimeter minus 8 millimeter. That will give us 80 millimeter. So if 100 degrees Celsius fundamental interval corresponds to 80 millimeter, therefore 64 millimeter would correspond to what? Therefore 64 will correspond to, sorry, therefore 64 millimeter, let me erase this. Therefore 64 millimeter would correspond to an unknown, x. How do you get this? We always cross multiply. We always cross multiply. So now let me cross multiply. I multiply this to x times 88, I get 88x. Sorry, not 88, that is 80. X times 80, I will get 80x is equal to 100 times 64. I will get 6,400. So in order to get x, I'll divide both sides by 80. Divide by 80. That means my x will be equal to 6,400 divided by 80. I will get 80 degrees Celsius. Okay, good. That is 80 degrees Celsius, which is option C. Hold on, hold on, hold on, hold on, hold on. Question 15, right? Question 15, but sorry. 80 degrees Celsius is option B, not option C. Sorry about that. 80 degrees Celsius is option B, not option C. So I have to wipe off all of this so I can get enough space to solve the next question. So question 16, that's the next question. Question 16 says, 4 thermometers with bulbs painted different colors are placed at equal distances from a radiant heater. Which thermometer shows the slowest temperature rise when the heater is first switched on? Okay, that has to do with radiation of heat, because it shows that they are placed at equal distances, and if you are heating something at a distance, the heat will get there through radiation. So it says which thermometer shows the slowest temperature rise, that's the poorest receptor of radiant heat, and the poorest receptor of radiant heat is the shiny white surface. That makes option D the correct answer to question 16. Let's go straight to question 17. A wave source produces 3,000 crests every minute. The wave has a speed of 300 meters per second. What is the wavelength? The formula for wave equation is velocity is equal to frequency times wavelength. That means wavelength is the speed divided by frequency. Now we were told that the speed, okay, the speed is 300 meters per second. So it's likely we are talking about sound waves here. While the frequency is the number of cycles produced rather in 1 second, the number of waves produced in 1 second. This question shows that it produces 3,000 crests. That is 3,000 waves are being produced every minute. That means 3,000 crests are produced in 60 seconds, because 1 minute is equal to 60 seconds. 3,000 divided by 60 will give us 50. That means the frequency is 50 hertz. Now you substitute this value into the expression for wavelength. So we have wavelength is the speed. The speed is 300 meters per second. So we have 300, okay? You know, it is speed divided by frequency. What's our frequency? Our frequency is 50 hertz. 300 divided by 50 will give us 6 meters, 6.0 meters. That makes option C the correct answer to question 17. Question 18. The diagrams show two sets of wavefronts in a ripple tank. You can see the first wavefront, yeah, and then the second wavefront. Now, in this case, a student makes two statements about the waves. Statement number one, when the waves when the waves reflect from the barrier, the direction changes but wavelength remains the same. Okay, during the reflection of wave, there will be a change in direction but wavelength remains the same. That is correct. Statement number two, when the waves refract as they enter the shallow water, the direction remains the same but the wavelength changes. During the refraction of waves, you see these waves that are coming in, after hitting this barrier, after hitting this barrier, this one will change direction to this way. This change direction, they change direction. So the direction of the wave becomes changed. Initially, the waves were moving in this direction, but after hitting the barrier, they all start moving in this changed direction. Hence, the direction of the wave does not remain the same. Hence, this one is wrong. Okay, so only number one is correct, which is option B, statement one only. Question 19. A composite block is made by joining together three transparent materials. The diagram shows a ray of light passing through the composite block. Which list gives the three materials in order of the speeds of light in the materials from the slowest to fastest? No, in this first case, when it's refracted closer to the normal and then away from the normal. So since it's been going closer to the normal, that means the from slowest to the fastest. Okay, that means the fastest is number three. Okay, the waves are very fast in number three. Okay, that's why is refracted further away from the normal. And if you look at this one towards the normal, this one is closest to the normal. Okay, while this one is a bit away from the normal, but not as much as number three. Okay, let me use this. I think this will make it easier to explain. So if you look at this, okay, this one is more slant. That shows that the waves is fastest. Okay, they are going from slowest to the fastest. And this number three, this last one has the fastest. That's where the wave will be fastest because it's farther away from the normal. Okay, this one too is a bit away from the normal, but this one is very close to the normal. If you try to calculate the angle of refraction is so close to the normal here. That's why the waves will be slow here. Okay, good. Hold on. Yeah, yeah. So the waves will be slow here, okay? But here, they will be a bit slow, but not as slow as here. But this is where the waves are fastest, okay? So this is where the waves are slowest in medium 2. Then this is where the waves have moderate speed, medium 1. So you are saying going from, yeah, so I'm not supposed to write a 1, 2, 3 here. I'm just supposed to write this is where the waves are fastest. So here the waves are a bit this way, here the waves are slow, and here the waves are a bit fast, but not the fastest. Okay, so the order will be 2, 1, 3, yeah, because 2 is the slow, followed by fast, which is medium 1, then followed by faster, which is medium 3. That makes option C the correct answer to question number 19. Now we go straight to question number 20. An object is placed 30 centimeters in front of a plane mirror. Which statement describes the image of the object? A. The image is same size and 30 centimeters from the object. 30 centimeters from the object. No. The image is the same size and 60 centimeters from the object. Perfect. Yeah, this is because if you have a mirror here and the object is here, the image can be here. If the distance between the object and the mirror is 30 centimeters, that means the distance between the image and the mirror must also be 30 centimeters. Okay, that simply means the total distance between the object and the image will be 30 plus 30, which is 60 centimeters. That makes option B the correct answer to question number 20. We go straight to question 21. Looking at question 21, it says a ray of light is shone onto the surface of a mirror. Which two angles represent the angle of incidence and the angle of reflection? During the reflection of light, this is our angle of incidence, okay, angle I, and the angle here between the reflected ray and the normal is our angle of reflection, okay. So 2 is angle of incidence, 3 is angle of reflection. That makes option C the correct answer. Question 22. The speed of sound in air is 330 meters per second. How do the speeds of sound in concrete and water compare with this sound? You know, sound travels faster in liquid than in gases, and sound is fastest in solid. So speed of sound in concrete will be greater, okay, while speed of sound in air is 330 meters per second. The speed of sound in water, the speed of sound in speed of sound in concrete will be greater, yes, of course. Also, speed of sound in water would also be greater than speed of sound in air. So both of them will be greater. Okay, so this is correct. This is correct, while others are wrong. So in which case do we have both of them being correct? Only option A, we have both of them being correct. Why? Because the speed of sound increases from gas to liquid, then to solid. Sound travels fastest in solids, okay, followed by in liquid, followed by in gases. Example, the speed of sound in air is 330 meters per second. But in water, the speed of sound in water can be around 500 meters per second. And in solid, like iron, okay, in iron, I'm sure of iron, the speed of sound in iron is around 1500 meters per second, okay. I'm not sure of the value in concrete, but so this is just an illustration to let you know that the speed of sound increases when going from gas through liquid to solid. What is the speed of question 23? What is the speed of microwave in air? Do not forget that all electromagnetic waves travel at the speed of light in vacuum. All electromagnetic waves travel at the speed of light in vacuum. And the speed of light in vacuum is approximately the speed of light in air, and that is 300 million meters per second, or 300 times 10 to the power 8 meters per second, which is option C. Sorry, not 300 times 10 to the power 8. 300 times 10 to the power 6. Yeah. 300 times 10 to the power 6 meters per second, or you call it 3 times 10 to the power 8 meters per second, which is option C. Question 24. An observer stands at the finish line of a 100 meters race. He wants to time the winner's run. He starts his stopwatch as soon as he sees the smoke from the starting gun instead of when he hears the bang. What is the reason for doing this? Here, the option says A, light travels much faster than sound. Correct. So since light travels faster than sound, then it will be more accurate if he uses the time when he sees the smoke, because seeing the smoke has to do with light. But hearing the sound of the gun, okay, hearing the gun has to do with hearing the bang of the gun has to do with sound. And since light travels faster than sound, then it's better he uses when he sees the smoke, because that involves rays of light, and light is faster than sound. Hence, he'll be doing it accurately. Okay, yeah, you get the start time accurately. Question 25. Which statement is not a method for magnetizing an iron bar? Option A, place the bar next to a magnet and hammer it. Hammering is correct, okay. Number B, place the bar inside a solenoid. Switch on an alternating current. You don't use alternating current to produce to magnetize an iron bar. Place in an alternating current and gradually reduce the current. You don't use a varying alternating current to magnetize the bar. Option C, place the bar inside the solenoid. Switch on a direct current DC in the coil and gradually reduce the current. DC can be used to magnetize, okay? Whether you are increasing the current or reducing the current, DC can be used to magnetize. Number D, stroke the bar repeatedly with a magnet. Correct. So the only one that is not correct, the only one that is not a method of magnetizing an iron bar is option B. So we shade option B as being the correct answer. I hope you get the question. The question says which is not a method and which is B. Number 26. The diagram shows a circuit containing a variable resistor connected to a variable power supply. The table shows the current for different values of potential difference and resistance. What is the order of current from smallest to greatest? Now use the formula from Ohm's law, V equal to IR. And to get current, current is equal to voltage divided by resistance. So let's do that for each of these. In the first case, our potential difference is the voltage. Our voltage is 3.6 and resistance is 12. So let's go 3.6 divided by 12, and that will give us 0.3 ampere. That's I1. Let's do that for I2. I2, that's current is voltage divided by resistance, and the voltage in I2 is 1.2. 1.2 divided by the resistance is 12 ohms. 1.2 divided by 12, that will give us 0.1 amperes. So I2 is 0.1 amperes. Okay, number 3, I3, current is voltage divided by resistance. Our voltage is 3.6, resistance is 6. So we have the voltage, which is 3.6, divided by our resistance. The resistance is 6. 3.6 divided by 6 gives us 0.6 ampere. Okay, so we are going from smallest to greatest. So the smallest is I2, followed by I1, followed by I3. And that makes option C the correct answer to the question. I3, followed by I1, followed by I2. Question 27. Which diagram shows the electric field pattern around a positive charge? Electric field pattern around a positive charge radiates outwards. This is the correct answer. This is for a negative charge. This is for a conductor, okay, a current carrying conductor. C and D are both for current carrying conductors, right? Good, not for electric charges. So we go straight to question 28. A negatively charged plastic rod P is placed above a positively charged plastic rod Q. What is the direction of the electrostatic forces on the rod P and on rod Q? According to the fundamental law of static electricity, on like charges, okay, or on the similar charges, they attract each other. Hence, since these plates are of opposite charges, these rod are of opposite charges, there will be attraction. That means that the rod Q will be the force on Q will be upward, driving it towards the rod P. Okay. Also, the force on P will be downwards, driving it towards the rod Q. Okay. That shows that option B is the correct option. Okay. The force on P will be downwards, the force on Q will be upwards. Let's go to question 29. A lamp rated 12 volts, 2 amperes is switched on for 1 minute. How much energy is transferred by the lamp? Do not forget that electrical energy is given by the formula IVT, where I is the current, V is the voltage, and T is the time. Okay, so the current is 0.2 amperes. The current is 0.2 amperes. Yes. The voltage is 12 volts. Yes. The time is 1 minute. But we don't use time in minutes, we use time in second. So that will be 1 times 60. Okay, that means our time is 60 seconds. Now let's use the formula for energy is IVT. So our current is 0.2, our voltage is 12, and our time is 60 seconds. 0.2 multiplied by 12, that will give, 0.2 multiplied by 60, that will give you 12. And 12 multiplied by 12 will give you 144. So our answer is 144. No, it's not there. What am I missing? 0.2 multiplied by 60, that will be 12. 12 multiplied by 12 will give us 144. What am I missing? What am I missing? How much energy will be transferred to the lamp? Number 29. Number 29. Okay, let me do this again. 0.2 times 12. A lamp rated 12 volts, yes, 2 amperes. Oh, 2.0 amperes, not 0.2 amperes. Sorry. Current is 2.0 amperes, not 0.2. So I'll write 2.0 for current. So I'll fix this. Our current is 2.0. 2.0. So I'll multiply 60 times 2 times 12. Yeah, 1 minute. 60 times 2 times 12. 60 times 2 is 120. 120 times 12 is 1440. Option D. That is the correct answer to question 29. Question 30. An alternating current AC power supply is connected in series with a resistor and a diode. Which graph shows the voltage across the resistor? Shows the voltage across the resistor varies with time. The graph C is the correct answer. Why? Because the diode will only switch on when this part is positive and this side is negative. When the polarity switches, the diode will not work. Now, you know, this is the wave, the sine wave of alternating current. But the diode will only be switching on for the positive side, okay? It will only be picking the positive side. It won't pick the negative side. It only pick this side, the positive side, positive side, positive side, positive side, because we have only one diode in this circuit. Okay, hence that is option C. That's what that's what the option C looks like, and that's the correct answer to this question. Question 31. A student makes 4 resistors using different pieces of wire. The wires have different diameters and lengths. All the pieces of wire are made of the same material. Which piece of wire would make the resistor with the greatest resistance? You know, according to the expression for resistivity is RA divided by length. You know, we are looking for resistance. Let's make resistance the subject. So resistance is equal to what? Rho L over A. So that will be resistivity times length over area. What that means is that when the length is high, resistance is high. When the area is low, resistance is high. So the question, which piece of wire will make resistor with the largest resistance? So the one with largest length and lowest cross-sectional area, okay, or lowest diameter. You know, diameter determines the area. So when diameter is big, area is big. When diameter is low, area is low. Um, so the diameter will be used to assess for the area. So diameter, the smallest diameter, these are the smallest diameters, and the biggest length, these are the biggest length. So where do we have the two? Option D. Option D gives us the smallest diameter and the biggest length. Okay, that makes option D the correct answer to the question. Question 32. Which diagram shows a circuit containing a battery, a fuse, and a buzzer? This is a fuse. This is a fuse. Yeah, this is a fuse. This is a buzzer. Yes. This is a battery. This is not the symbol of buzzer. This is not the symbol of buzzer. This is not the symbol of a fuse. Okay. This is a fuse, a symbol of of um of a photoresistive material. Okay, that's the symbol of a photoresistive material. So this is not the symbol of a fuse. So the only correct answer is option B. In option B, we have a fuse, we have the buzzer, we have the battery. Okay, that makes B the correct answer to question 32. Logic gate, for those of you that have not done logic. Now, the diagram shows a network of logic gates. The diagram shows a network of logic gates. Which logic gates placed between X, Y, and out would have the same effect as the network? That means if we replace this entire network with something like this, we place something between X, Y, this is Y, and the output. There's something that will place here between X, Y, and output, and it will have the same effect as the original question. What is that thing? That is the NAND gate, and this is the NAND gate. For those of you that have not done logic, this is the symbol of an OR gate. This is the symbol of an AND gate. This is the symbol of a NAND gate. NAND, that is not and. NAND. This is a symbol of a NOR gate. Okay. This is a symbol of a NOT gate. This one here, it means not. That means it is not X. So if you look at it, this shows that let me erase this so I can write. Yeah. So this first one shows that it is not X and it is not Y. Okay. Why here we have AND. Okay. That means not X that is coming here and not Y that is coming here. And that's why we call it the NAND gate. Not X and not Y. That's why we are representing it with the NAND gate. This you'll be learning when you when you get to A level, and also in university if you are studying electronics or electrical engineering or you're studying physics, then you deal with logic gates. Okay. But for now, let's focus on how you pass your IGCSE examination. Let's go straight to question number 34. The diagram represents a transformer. We have the primary coil, we have the secondary coil. Which row shows the material suitable for making the core and primary coil? The core of a transformer must be made of soft iron, okay? Laminated soft iron, while the coil must be made of copper. Yeah. So the core is iron, while the coil is made of copper. That makes option A the correct answer. Iron, so it can direct the magnetic field, while copper, it has low resistance, hence the coil will not heat up. Okay. Yeah. The coil will not heat up because copper has very low resistance. Yeah. So let's go straight to question 35. The diagrams show the magnetic field lines around a wire carrying a current. Which diagrams are correct? One only. Okay, so if you have according to the thumb rule, okay, or the right hand grip rule, if you have a conductor and you grip it with your right hand with your thumb pointing in the direction of current, the direction in which your fingers wrap that conductor, it shows the direction of the field. Okay, and this number one is correct. Okay, number two, number two, number two, these arrows are correct, but these arrows are not correct. So that shows number two is not correct. Number three, okay, if you turn it the other way, upside down, number three, number three is correct. Number four, you turn it upside down, number four is not correct because the direction of these arrows is very wrong. So one and three is the correct answer. That makes option D the correct answer to question 35. Question 36. Which statement about electromagnetic induction is correct? Which statement about electromagnetic induction is correct? Number one, a conductor moving parallel to magnetic field lines induces an electromotive force in the conductor. Okay, number one is correct. Number two, the direction of the induced electromotive force opposes the change which produces it. Sorry, this is number 36, right? Number 36, A says a conductor moving parallel to magnetic field lines induces an electromotive force in the conductor. So when you have a conductor that is moving parallel to magnetic field lines, then an electromotive force would be induced in the conductor. Okay, number B, the direction of the induced electromotive force opposes the change producing it. That's correct. Number C, the induced current is in direction parallel to the direction of motion producing it. That is not correct. Number D, the induced electromotive force decreases when the speed of the conductor moving across the field lines increases. That's not correct. Let me look at number one again. A conductor moving parallel? No, no, no. The conductor must not move parallel to magnetic field lines. The conductor must move perpendicularly to the direction of the magnetic field lines. I didn't take note of this statement. So when you say parallel, the conductor is moving in the same direction. Hence, it is not cutting across the magnetic field line. So that one is not correct. Option B is the correct answer. So to make excellent grades in this exam, you must read carefully each question. Ensure you are not in hurry. That means you must try as possible not to spend much time in questions that don't require you to think much. And questions that require you to think much, ensure you have enough time to spend on them. Question 37. A very important experiment increased scientists' understanding of the structure of matter. In the experiment, particles scattered as they passed through a thin metal foil. Which particles were used and to which conclusion did the experiment lead? Alpha particles, correct? Then option A says alpha particles, that's correct. Matter is made of atoms. That's also, matter is made up of atoms. That did not make us know that matter is made up of atoms. Option B, alpha particles, that's correct. Atoms have a very small nucleus. That's also correct. Option C, beta particles, no. D, beta particles, no. Option B is the only correct option. That's the experiment carried out by, I think it's Rutherford, yeah, that directed a beam of alpha particles at gold foil, and the gold foil made the beam of alpha particles scatter. Okay, the experiment, we shouldn't be doing this here, performed by Rutherford, by Rutherford, that when he directed okay, when Rutherford directed a beam of alpha particles, alpha particles on gold foil. Okay, so sometimes you just have to Google it to confirm. So Rutherford and the nucleus, and as Rutherford did an experiment to test um, the plum pudding model. His two students, Hans and Geiger-Massen, directed a beam of alpha particles at a very thin gold field foil suspended in vacuum. So that is when we detected this model of the atom. So you can just waste time to go through it. Let us finish what we were working on. Question 38. Polonium, PO, has a proton number equal to 84 and a nucleon number equal to 218. Polonium changes into astatine 80 by emitting a beta particle. Which equation represents this decay? Polonium Polonium has a nucleon number of 218. It changes to astatine by emitting beta particle. Do not forget, beta particles are electrons. Electrons have atomic number of -1 and charge of and mass number of 0. Okay, good. So which equation does this look like? This looks like option, let's see. Polonium has atomic number of -1 and charge of and mass of 0. Sorry. Did I just say polonium? An electron has an atomic number of -1. An electron is a beta particle, and we always represent it as something that has atomic number of -1. Okay, since the charge of the electron is -1, it has atomic number of -1 and mass number of 0. So which equation is that? This is the beta particle. That's correct. This is astatine. Okay, that's also correct. What about the atomic number? Is it balanced? 85. 85 minus 1. Yeah, if you work on these two, 85 minus 1 gives you 84. And that's what we have here. So option C is the correct answer. Why did I say that? Because if you add them up, add 85 and minus 1 together, you get 84. Okay, and the mass number, there's no difference in the mass number. Why? Because the mass of the electron is 0, so the mass would not change. That makes C the correct answer. Question 89. The graph shows how the count rate of a radioactive isotope changes with time. What is the half-life of the isotope? Half-life is the time taken for half the um, um, number of atoms to decay. So initially, what do we have here? Initially, we have 0, 1, 2, 3, 4, 5. 5 gives us 10. That means each division is 2. Each division is 2. So 50, 50 from 50, okay, so we'll go from 50. From 50, we go one division up, that's 52, because each division is 52. 52 plus half, that will be 53. So that means the value here is 53. So half of 53, let's go back. Half of 53, let's go here. 53 divided by 2, that will give us 26.5. So when do we have 26.5? When do we have 26.5 as the count rate? Let's come back here. Let's come back to the graph. So this is 30, this is 20, this should be 25. 26.5 should be somewhere around here. So that means this is where we have 26.5. Okay, hence the half-life should be around 2 seconds. Yeah, the half-life should be around 2 seconds. So that is option A. A is the correct answer to question 39. I hope you understand the steps I took while looking for the answer. So let's go straight to question 40. What is the nature of alpha emission? Alpha particle is a what? Is a helium nuclei, He2 plus. That's helium that has lost 2 electrons. So let's see. Electromagnetic waves, no. Helium is not electromagnetic wave. Negatively charged particles, no. They are positively charged. Positive charged particles, correct. Uncharged particles, that's not correct. So the correct answer to question 40 is C. This brings us to the end of the Cambridge IGCSE October-November 2022 paper 2 variant 1. Paper 2 variant 1. Okay, so if you have enough time, we go through paper 2 variant 2. If you don't have enough time, then tomorrow later today I'll be uploading the video of paper 3 and paper 4 for students that will be writing their theory exams very soon. Thank you for watching. ensure you subscribe to this YouTube channel and share this video with your friends. Do have a nice day. Goodbye.